So we're going to focus today on using logs to solve equations. When we're solving log equations, we have to really be careful of checking for extraneous roots. There's many restrictions on logs. The base can't be negative or equal to 1. Okay, our arguments can't be negative. We have to be careful of these restrictions, and we can often get extraneous solutions because of them. The other thing is there are many different ways to solve log problems. So I might show you a couple for different ways for one problem, but there are many different ways you can solve log problems as long as you apply the log properties correctly. Our definition of log, our log laws, our multiplication, power, division rules, okay, and our change of base formulas. As long as we apply these correctly, we should be okay. However, if you make an error with any one of them or misapply any of them, we have the log equations. Obviously, we're not going to get a correct solution to those. Okay, so let's look at some log equations then. Okay, so I want to solve for x, which means I have to undo everything around here. So I've got a +1 I have to undo. I've got a log base 4 I have to undo. So I'm going to start with that +1. So I'm going to undo that +1. And I'm going to undo that with a -1. Okay. Now I need to undo the log. Well, I can undo log with an exponent. So I'm going to convert this log into exponential form. So I end up with 4 to the power -1 equals log base 16 of 2x. Again, I can undo this log with another exponent. So this is equal to 1/4. So that's my power. And I'm going to use that power to undo this log. So I end up with 16 to the 1/4, which is a 4th root, and that's equal to 2x. Okay, so the 4th root of 16, I'm running out of space here, so the 4th root of 16 is going to be 2, and that equals 2x. So we get solution x equals 1. Okay, so when we get the solution x equals 1, we have to make sure that that solution is a valid solution. So if I plug it back into here, I'm going to get a valid solution for x. So x equals 1. Yeah, I can take the log base 16 of 2. Okay, that's going to be equal to 4. The log is going to be -4, I think it is. Okay, so we are going to end up with log base 4, of 1/4. And then so we're going to end up with log base 4 of 1/4, which is -1 plus 1 is 0. So that works. Okay, so we have to plug it back in to make sure that this, in fact, solution is valid. For this one here, we need to solve for log y. So there's two ways to solve this one. We could, strip off the log and solve it as an exponent, solve for y, and then put it into a log form. Or we can just isolate the log y as is. Okay, so I'll do this one in two ways. So if I'm going to solve for the log y, I need to get rid of that times 30. Well, that's easy. I can get rid of times 30 with a divide by 30. Okay. I need to get rid of this log. Well, I don't want to get rid of the log. I want to keep the log. But I could get rid of the log and solve an exponent. So that's an alternative solution, which I'll show you as well. But here I just want to get rid of that times 2 inside here, and I want to get rid of that power 5. Well, I can get rid of that using some log properties. Okay, so I can split that 2 with the y to the power 5. Okay, I can do that using log properties, and I can use another log property to bring that 5 to the front. So I'm just going to do that in one step here. Okay, so there I have my log 5. Now I just have to move everything to the other side. So I end up with x over 30, okay, minus log 2, all divided by 5 equals log y. Okay, and this is a perfectly valid solution. I probably should simplify this, put it under a common denominator, or something like that, but this is good enough. Okay, this is a perfectly valid solution. I've isolated the log y. I'm just gonna put it under a common denominator. So it looks like my common denominator is going to be 150. Okay, so I'm just going to put this under 150. And this is going to be minus log, so it's going to be minus 30 log 2. Okay, so that's a perfectly good solution.